getting there.
Take a minute. Is that on?
We went to do. You're doing CO2. You said?
Yeah, CO2.
I'll let you run it.
Oh, okay.
I don't know where your stuff is.
Yeah. Do you want to do the?
Just do some on-offs. Just a few rounds, just to see.
I mean, do we need to check the peak center first?
To check the what?
Peak center.
I just did. It looks good.
Oh, okay.
Yeah. It'll automatically peak center when you start doing the.
Right. Yeah. Okay. Let me find the sequence. Okay. Run. I don't know. Let's see this one. Let's run this one. We need to do like a CO2, right?
Yeah, I do.
Zero.
I do a bunch. If you have a file that has a bunch of them.
Yeah.
If
So
not, we can just make one.
it's NLK carbon GC. Yeah, we can use this one. Maybe with 7 new sequence, maybe. Into 0427. This is inspection. Okay, new sequence. So I what's this? Is this or yeah, A6? I don't need. Oh, maybe I can delete.
Oh wow, that's quite a run.
They're quite lazy. They just add append the sample to the delete. So save. This is holder 1, slot 1, position 1, 1.5 micron, meter A6. Yeah. Don't know how much we have here. It's for hydrogen. Don't know which one. Okay, let's try. I don't know. Maybe.
Okay, can I see this for 1 second?
Yeah, you go ahead. I mean,
We'll move samples. Cool. All right, let's see how.
alright. So it's doing 0 now.
It will. It'll do its checks, peak center,
Oh, yeah.
and all that, and just do a bunch of zeros.
Okay.
It's usually, especially after a long time interval, I'd run quite a few just to make sure it's stable. And I'm just interested to see the peak shape and see how bad the standard deviation is. But I mean, your water background came down to 5 volts and it was still going down, so that's great. Without the analyzer heater on.
No.
So it's looking good. I think after just a few hours, like the 12 hours tomorrow, it might be fine.
Okay. Do you want me to do the analyzer heater overnight?
Yeah.
Okay.
So like I set it to the 12 hours.
Uh-huh.
What is today? Wednesday?
Yeah.
Yeah. So what I would do on Friday, before you leave, I'd set it for 72 hours or something like that. I'd set
Okay.
it, you know, if you're not gonna come in on the weekend,
Mm-hmm.
I'd set it to, you know, shut off Monday morning at 5 a.m.
Okay.
This way, it'll bake all weekend long,
Uh,
and it should be good. And I'd have it baked with both of the valves open,
Mm-hmm.
and all the heaters on.
Both needle bulb open.
Yeah, both heater valves open. As long as the gas vent is hooked up to helium, right?
Yes.
Yeah.
Helium is on.
Yeah,
To the
yeah.
gas bench.
So I'd open up both needle valves, make sure keep the filament on,
Keep.
keep the filament on, like keep the source on,
Yes.
and turn on all the heaters and just let it bake out the
Okay.
whole system over the weekend.
Sure. So.
And then when you come in on Monday, just do a ton of on-offs. You know, like do like 20, and make sure that the standard deviation is consistent. Do fuel linearity checks, make sure those are consistent, and this way you'll know for certain that the system's stable.
Okay.
Because like, if you did 5 and they're consistent, I don't know if I'd believe it. I'd do 20. I'd do a bunch of them
Sure.
on Monday, just to make sure.
You mean 0.
Zeros,
Yeah.
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 Sorry, everyone goes with something different. Yeah,
Okay.
I'd do 20 of the zero enrichment, and you know, check every fuel, but make sure the standard deviation seems like it's consistent. Because if it goes from 0.02 to 0.6 to 0.02 to 0.1, it's showing that there's still variability in the 10 peaks. And
Okay.
That may suggest something different than if it's consistent. You know, it's always going to vary a bit, but I want to make sure that that bake out did something.
Mm-hmm. Yeah, this mass spectrometer was excellent.
Yeah.
I mean, that's the old 253. We got pretty similar resolution,
Really?
Yeah.
Awesome. That's great.
and it's pretty stable for these 5 years.
Great.
But I just don't know the future,
Yeah.
what damage might do bad things to the mass spectrometer.
Those peak shapes don't look like the best.
Still not the best.
No, see how they kind of ramp
yeah,
up?
so the
Yeah.
flange. Yeah.
Yeah. But, I mean, that's to be expected. This is the first set.
So ideally those look flat?
Yes.
Okay.
And even when they're flat, ideally they're flat and they're not noisy. So like when you would zoom in on them.
Yeah.
It's a straight line.
Oh, okay,
You know, obviously because of the scale, like it's gonna have, if you zoom in far enough, it's gonna have deviation.
Oh, sure, yeah. Okay.
But it shouldn't, you know, what you can do is look in archived on-offs and make sure you pay attention to the scale
Yeah.
and see how wavy it was when you know you had really good data, and then compare them what you have now.
They're supposed to have the same intensity, but why sometimes I see pretty different.
Yeah, I just think it's been closed for a while and you had the water, and it just needs to
Okay.
work the kinks out.
Sorry, so when you say on-offs, what are you talking about?
These are on-offs.
Okay,
Yeah.
So-
okay.
They're also called zero enrichment tests or just zeros.
Okay.
There's several names for them. It all means the same thing. So what this is doing is inside the conflow, the CO2 is always flowing conflow, consistent flow. It's just that the capillary is going up towards the sniffer for 20 seconds and then back down, and then up and then back down.
Oh, okay.
So the goal is to get, around 10 of the reference peaks, and then look at the standard deviation between them, and they should be less than 0.066.
Okay. And so when you say we should run 20 on-offs, you're saying we should set up a run that does 20 of those peaks, or we should do 20, this whole process 20 times?
Yes, 20 of this whole process.
Okay.
Good questions. Yeah. So one set of on-offs is usually 10 of the reference peaks. That would be like one on-off run, or
On-off run. Okay, got it. Okay.
1 zero enrichment run.
I already do 10. Maybe for the normal analysis, I do 10, 0, zero linearity.
Yeah.
If everything looks good, then I run samples.
Yeah, so after you do the on-offs, aka zeros, aka zero enrichments,
Got it.
you do a linearity check. And that's where the intensity is going on.
That's kind of a linearity.
Yeah. So when you do linearity, it'll inject. How do I explain this? It'll inject the same amount of reference gas, except you have helium diluters in there, and the helium dilution will decrease the intensity of the CO2. So you'll have one peak at 1,000 millivolts, another peak at 2,500, another peak at 3,000, another peak at 4, etc. We have like 7 to 10 peaks.
Okay.
And the goal is, you want to make sure, well, not you, but the program will make sure that the isotopic value does not change with the intensity. So you can imagine if you're looking at samples of different concentrations of the standard,
Yeah.
if you'd see different isotopic values, that's not right because it's a standard.
Okay.
That is a known. So at that point you'd know that there is a linearity.
Okay.
So a linearity test should have a minimal linearity.
So it's just checking that there's no variability based on concentration.
No variability based on the voltage, which would be concentration. So there's going to always be some, but there's a limit, and the limit is 0.066 per mil.
Okay.
And you don't want to check that in isodat. You want to check that in Excel.
Okay.
So you'd make a plot.
Let's export the data.
You don't even have to export the data. What you do is you might want to write this down. Unless
Sure.
So you'd copy mass 44. Let me know when you're ready.
Okay, go for it.
You'd copy mass 44.
Okay.
Oh, 2 monitors are so amazing. That is so nice. Everyone should have 2 monitors.
So copy mass 44.
Yes, sir. We just went to
we finished
the
one.
next one.
Yeah, we go to result and check out.
Okay. The copy, you just right clicked on it, on that column.
Where are the results?
Where's the two dots? Oh, this is a gas bench.
Oh, that's why. Okay.
Yeah. Here we
There
go.
we go.
Yeah. There we go. 22.
Yes.
Okay.
All right. So you'd right click on mass 44. Copy. Paste. And then we have a lot of columns.
That's not, yeah.
And then you right click on
45.
yeah, where? Oh, here we go. Paste that, and then you calculate the slope in here. 'Cause if you do it on here, I'll wait till you're done.
Yeah. Sure.
You good? If you do it on here, right click, you go to calculate. It'll give you a regression slope,
Okay.
but you don't know what it's giving you a regression slope of. It's giving you the regression slope of this, but compared to what? Nobody knows.
Nothing.
So in order to do it
Whoa.
mathematically, it's slope, parentheses, one column, comma, the other column, end it. Then you get a slope. Now the slope's in per mil, so it should be times 10 to the negative 5. like I think 6.6 times 10 to the negative 5 would be the limit.
Say that again. What's the limit?
I think it's 6.6 times 10 to the negative 5. Anything greater than that has not passed spec.
Your
So-
your slope.
Yeah. So if you look in the book, in the manual, it'll say 0.066, but it's 0.066 per mil.
Yeah.
So you got to take those extra zeros into account with this.
Sure. Okay.
Yeah, you just times out here.
It's
Yeah.
a negative slope.
You can.
It doesn't matter if it's negative or positive. It's
Okay.
just the slope.
Okay.
Yeah, you can time southern here. This is the slope.
Yeah. So it's bad.
Okay.
But most things don't pass within the first round.
Yeah, that's the first to come
Oh,
up
so that's why you're saying do it
Yeah.
20 times or whatever.
Yeah.
Okay.
So like this is looking better already. The peak shape looks a little bit better, and the intensity is not increasing.
Okay.
So one reason why the intensity could be changing is because the all the gas in there, it's still reaching equilibrium, right? We saw mass 18 was going down,
Yeah.
argon was decreasing.
Right.
So we want to make sure that before we believe any of these numbers that everything's stable. And it really wasn't. I just wanted to see if this was completely screwed up, and it's not.
Okay.
So it looks like
It's still functioning.
for all intents and purposes it's working. But yeah, obviously we're going to go through with the whole insurance thing.
But as I said, like some lab had a pretty similar problem.
Yeah.
The long term,
Yeah.
you got
yeah,
a bad.
yeah.
Sometimes
Yeah.
they, it's a very erratic,
Yeah.
give you very bad results.
Yeah.
You don't know.
Yeah.
And it's unpredictable.
Yeah, completely. So yeah, I just wanted to make sure before I left that you'd know if you could run anything on here or not.
Okay.
And I mean,
At least
this looks like it's going to be good.
but not for hydrogen. You cannot run the HTC on only combustion.
Yeah.
Right.
Do you have a new reactor that you could swap?
Yeah. Yes. Yes. We
Okay.
have.
I don't think that's going to do anything. There's probably something else that's screwed up that you might want to just change it and see what happens. And if that doesn't work, then put the old one back in.
Okay. Yeah, this reminds me